Okay, hi everyone. My name is Abel Gray Cantoma. I'm from GREYTEST Card Concept. This is actually my WhatsApp contact. Okay, you can reach me on any of these numbers. You can call me. Okay, these are the list of softwares we have covered on our YouTube channel. You can visit that channel down below the description of this video. The link to that channel is actually there. Visit the channel to actually keep yourself busy. Okay. We now teach all of these softwares on our Telegram platform where we'll give you the softwares, we'll guide you on how to install it, and then how to crack it on your system as well. And then we'll guide you through the process of design until you attain mastery. Amazing, right? Today, I'm going to be taking you through um, simply supported BIM with uniformly distributed load. Now, so we have this diagram this way. Okay, you notice I make this a small letter W. Total length here is actually L. We have a reaction here. We have a reaction here. Okay, this is point A, this is point B. Okay. On this video, on my next video, I'm going to be showing you how to I'll be explaining more about support, hinge support, roller, and then fixed support. I'm going to be explaining that better. Okay, but on this video, I'm just going to be concentrating on how to actually do this analysis on a uniformly distributed load. Okay, on a simply supported beam. Okay, because I discovered a lot of people have actually missed out in these, so they actually find structural analysis much more difficult to understand. So I'm going to be explaining this, and I believe you're going to understand it. Okay, right now I'm going to be now we have a vertical forces here, RA, and our RB. Our W is actually a uniformly distributed load. In order for us to make this a point load, actually it's going to be WL. Okay, now to make it actually a pointed load. Okay, so it's actually with respect to the span, the distance that actually cover. Now it is actually covered the whole of this. That is why it's called uniformly distributed load, and it is uniformly distributed on this whole beam. So we have our RA here, we have plus RB. Now the third law of motion states that in every action there must be equal and opposite reaction. Now what that means is that whatever that is coming down should actually be equal to whatever that is coming up. Now if that is correct, if we have 20 that is actually coming down, 20 should actually be what is coming up. Okay, now if that is correct, we have W equal to WL. I can rewrite this by saying, now this is summation of particle forces, please. I can write this by saying RA plus RB minus WL now equal to 0. What that means is that our downward forces are actually negative, upward is actually positive, clockwise is actually positive, okay, and then anti-clockwise is actually negative. Now if that is correct, I can actually let me name this my equation 1. Okay, and then if I take the summation of moment at point A, for example, equals to 0. Now, moment is actually force times the perpendicular distance. Okay, now you agree with me that we don't know this, they are both unknown. Okay, so whatever we get, this and this is supposed to give us equal to what is here. Okay, so we are going to actually prove that briefly on this. Okay, now our since we are taking moment at point A, our RA is gone because at this point here there is no distance that is covered. So in that case, our RA times the perpendicular distance will be 0. Anything multiplied by 0 is actually 0. So it's actually going to go. Now let me just show you that briefly. Equals to 0 plus RB multiplied by L. From here to here is L. Okay, minus our WL multiplied by L all over 2 equal to 0. Now we're just going to have RBL equal to, if we take the whole of this to this other side, it will be WL square all over 2. Now to take away this, we divide both sides by L. Okay, which is going to be our RB will be equal to WL all over 2 dot 1 all over L. I hope you understand what is going on here. So we're going to have RB equals to WL all over 2. Okay, you can see that the L here has cancelled out with this other L. Okay, that is why it is like this now. Now if that is correct, I'm just going to have if I substitute RB equal to WL in equation 1, this is going to be our RA plus WL over 2. That is, anywhere I see RB, I make it WL over 2 equal to WL. Now this is actually going to be RA equal to, now I'm looking for RA, WL minus WL all over 2. Now common factor of this and this is definitely going to be 2, so we are going to have 2 here. This is going to be 2WL minus WL equal to WL all over 2. So therefore our RA is equal to RB is equal to WL all over 2. So here we are going to have WL over 2 plus WL over 2 equals to WL from this equation. So wherever we see RA, we'll put WL over 2. Wherever we see RB is WL over 2. So this is just what is happening here. If you sum the both of these, if you take 2 downward here, this goes here, 2 goes here, 1, WL plus WL. Okay, this is going to give you, now from our left hand side please, okay, this is going to be 2WL all over 2. So the whole of this goes with this. So you discover that our left hand side is actually equal to our right hand side. So if you take this at this equation here, this is definitely going to give you 0 because the RA plus RB is equals to WL, and then this is actually also WL. So it's actually going to give you 0. This and this will cancel out. Now if that is correct, let's say this beam will actually take a section of this at any point please. Then we take this, this is this WL over 2, and then this, we have this. Remember, clockwise is positive, Anti-clockwise is negative, downward is negative, upward is positive. Okay, you discover I made this small letter W because it's actually uniformly distributed load. Okay, summation of vertical forces equals to 0. Downward QX minus downward W times the perpendicular distance. We have a new distance now, which is X. Okay, plus WL all over 2. Everything is equals to 0. Here we have WX equal to WL all over 2 minus WX. Okay, here we are going to have we say when X is equals to 0, from this equation, from here you can see we have WL over 2 minus, now here when it's equals to 0, we have WL all over 2, so it's going to be WL all over 2. And then when X is equals to L over 2, we have WL over 2 minus W. When X is equals to L over 2, we are going to actually have actually going to have WL over 2 minus WL all over 2. So we cancel out, we have 0. Here is going to be 0. Okay, and then when X is equals to L, we have WL over 2 minus W, okay, L. Okay, this is actually going to be, since this is a fraction, we're actually going to make this a fraction as well, over 1. So we have 2 here, this is a common factor. Okay, 2 here goes here, 1. We have WL minus 2 here goes 2. Okay, so we are going to have minus WL all over 2. So here is going to be equal to minus WL all over 2. So if we take a summation of moment, okay, at X, we are going to have minus MX. Remember I said clockwise is actually positive, anti-clockwise is actually negative. You can see this is actually going anti-clockwise, so that's what makes it negative. This is actually going downward, which is actually negative as well. So minus mx minus wx times the perpendicular distance, since we are taking our moment at point x. Okay, this is xx, please. Okay, so it's actually 0 minus wx, okay, which is actually this wx, okay, times the perpendicular distance, which is actually x all over 2, plus your WL all over 2. Okay, here we're going to have MX equal to WL all over 2 times the perpendicular distance minus, this would definitely go, okay, minus WX square all over 2. If you multiply this by this, So moment mx. Now when mx is equals to 0, we are going to have when x is equals to L over 2 and when x is equals to L. So we're actually going to check for this now. What are we going to have? Okay, so WL when x is equals to 0 over 2 minus W, okay, minus W when x is equals to 0 squared all over 2. Okay, everything actually goes down to 0, so we are going to have here 0, so here is going to be 0. And then when x is equals to L over 2, we are going to have WL into L over 2 W into L over 2 all squared all over 2. So here we're going to have W L squared all over 2 plus 1 L over 2, okay, minus W L squared all over 4 get 1 over 2. This is going to be WL squared L over 4 minus WL squared L over 8. Okay, so if we take this, there's going to be 8. So we have 2WL squared minus WL squared. Okay, so here we're going to have WL squared all over 8. Okay, when x is equal to L, so here we have WL squared over 8. So here I'm going to write WL squared all over 8. So when x equals to L, when x equals to L here, we're going to have WL multiplied by L all over 2 minus W L squared all over 2. Okay, this is actually the same thing. Is going to give us WL squared all over 2 minus W L squared all over 2. This goes with this. This actually equals to 0. So here we have 0. Now you can see that our result, our answer here when L over 2 is equal to, it's actually parabolic. If you can have, you have WL square L over 2 is actually quadratic. Okay, it's quadratic, it's parabolic, it's quadratic, yes, it's square. Okay, now if that is correct, let's go and design our bending moment and our shear extent. You get to understand that that of point is found, and that of for your moment, and that of being only distributed with this axis parabolic. Parabolic. If that is correct, yes, we have your uniformly distributed load. For our shear, here we have now if we check for our share, you can see we have at X we have WL over 2, at L we have minus WL over 2. So at X we have WL over 2, here we have minus WL over 2, and then at the midpoint we have 0. L over 2, at midpoint, which is L over 2, we have 0. So it's going to look like this. Okay. While our bending moment you discover that at X we have 0, at L over 2 we have WL over 2 squared, or WL squared over 8, then at X we have 0. Okay, so this is 0 here, this is 0. So since it's positive, WL squared all over 2, and it's parabolic because of it's quadratic, okay, because of the squared, it is WL squared all over 8. So it's actually going to be parabolic. So this is actually how it's going to look like, which is WL squared all over 8. Now, if that is correct, if you are able to get to this point, I tell you congratulations. Okay. If you like what you have seen, make sure that you give it a thumbs up. Subscribe to this channel, is actually free. Click on the bell icon so as to always get a notification whenever I post videos. I post videos on softwares, I post videos on mathematics, engineering mathematics, and I post videos teaching how to analyze and actually how to design manually as well. Okay. Make sure that you stay safe and make sure that you actually stay blessed. Okay.